This is section 5.6 on half-angle identities, and this is the last section of this chapter, so the last group of identities that we will work with in this chapter. Half-angle identities come from the double-angle identities. That's why I have this page 517 down here with the double-angle identities, so you can compare them. 3 of the half-angle identities have a plus or minus symbol in front of them. And this indicates the sign is chosen based on the function under consideration and the quadrant of a over 2. So let's go down to the double angle identities and look at this one here. If we write an alternative form of this identity and solve for first cosine squared, do you see how we would add the 1? And then divide all that by 2. And then if we replace the a with a over 2, and then take the square root of both sides, you'll end up with cosine of a over 2 is equal to plus or minus the square root of 1 plus cosine of a over 2. Now this whole thing is underneath the square root, so be sure to write that when you're doing your homework. You see that we have 2 options, either a plus or a minus. So we will determine whether it's a plus or a minus. It all depends on what the value of cosine of whatever the quadrant is of a over 2, whatever that is in. So if a over 2 is in the first quadrant, then cosine of a over 2 would be positive. But if a over 2 is in the second quadrant, then cosine of a over 2 would be negative. So it all depends on that. It will make more sense when you do some problems in just a little bit. Sine of a over 2 comes from an alternative form of this double angle identity. If we subtract the 1 from both sides and then divide both sides by -2, take the square root, and then replace the a with a over 2, we will have sine of a over 2 is equal to plus or minus the square root of 1 minus cosine of a all over 2. So you see the difference between cosine of a over 2 and sine of a over 2? All that's the different is here we have a plus in the numerator and here we have a minus in the numerator for sine. Now there are different ways to derive tangent of a over 2. We can use what we have here with sine of a over 2 divided by cosine, because that's using the quotient property, and if we do that we will have plus or minus the square root of 1 minus cosine of a over 1 plus cosine of a. Because the 2's will divide out. And then the other 2 are actually a little simpler to use. And the second one is sine of a all divided by 1 plus cosine of a. Or we could have 1 minus cosine of a over sine of a.